In the ever-evolving landscape of global defense, the role of air superiority remains paramount. Fighter jets, once built purely for speed and agility, have undergone a radical transformation, emerging as high-tech marvels of engineering, data integration, and stealth capabilities. This is the story of how cutting-edge technology is shaping the next generation of fighter jets, an inside look at the systems, science, and innovations that define modern aerial warfare. Modern fighter jets are no longer just machines of speed and firepower. They are intelligent platforms that combine artificial intelligence, advanced avionics, and integrated weapon systems. The most prominent example of this evolution is the fifth-generation fighter jet. Unlike their predecessors, these aircraft are built from the ground up with stealth in mind. Stealth is not simply about shape, it's about materials, emissions, and tactics. Advanced radar-absorbing materials coat the skin of the aircraft, diffusing electromagnetic waves and minimizing detection. The airframe itself is sculpted with angular lines and internal weapon bays that reduce radar cross-section, making it harder to track by enemy radar systems. But stealth is only one piece of the puzzle. At the core of next-level aviation lies sensor fusion, a process that compiles data from multiple sensors across the jet to create a single, coherent picture of the battlespace. Modern jets like the F-35 Lightning II use this capability to provide the pilot with unprecedented situational awareness. Information from radar, infrared cameras, electronic surveillance, and even satellite links is processed and displayed via a helmet-mounted display, turning the pilot's visor into a 360-degree digital battlefield. Instead of scanning traditional cockpit dials and gauges, pilots now simply look in the direction of interest to lock onto targets, navigate, or communicate with their team. Artificial intelligence and machine learning are beginning to play a bigger role as well. These systems can predict maintenance issues before they arise, optimize flight paths, and assist pilots during combat scenarios. Autonomous drones, known as loyal wingmen, are being developed to fly alongside manned fighter jets, acting as decoys, weapons platforms, or reconnaissance tools. These AI-driven drones can coordinate with human pilots in real time, adjusting strategies on the fly, expanding the range and impact of each mission. Powering these marvels of aviation requires immense thrust-to-weight ratios and advanced propulsion systems. The engines in modern fighter jets are not only faster but smarter. Variable cycle engines, currently in development, will be capable of switching modes for greater efficiency in cruise and maximum power in combat, adapting to mission requirements mid-flight. Heat signatures are reduced with innovative exhaust designs to improve stealth, while afterburners provide explosive acceleration when speed becomes a tactical necessity. Electronic warfare is another frontier where technology is redefining what it means to fight in the skies. Modern jets are equipped with sophisticated jamming systems that can blind enemy radar, disrupt communications, and deceive incoming missiles. Some aircraft have active protection systems that can detect and destroy incoming projectiles using directed energy or countermeasures. Cyber capabilities also play a role, enabling aircraft to hack, disable, or control enemy networks and systems remotely. The cockpit itself has undergone a transformation. Touchscreen interfaces, voice command systems, and augmented reality overlays streamline complex operations. Pilots are trained to operate in this highly digital environment through advanced simulators that replicate combat with stunning realism. Virtual and mixed reality systems immerse pilots in scenarios that test reflexes, decision-making, and coordination, preparing them for the chaos and fluidity of real-world engagements. Communication and data sharing among aircraft, ground units, and command centers are facilitated through high-speed data links and cloud-based battlefield networks. These enable seamless coordination, where one jet's radar might detect a threat, and another jet, without ever turning on its own sensors, could act on that information. This kind of network-centric warfare ensures faster, smarter, and more lethal responses. Fueling the development of these technologies are multinational programs and collaborations. Countries are investing billions into joint fighter development, combining expertise, resources, and industrial capabilities. From the American F-22 and F-35 programs to the European Future Combat Air System and the British Tempest Initiative, global defense industries are racing to define the sixth generation of air dominance. All of this is happening within the constraints of increasing operational costs and geopolitical pressure. Engineers are tasked not just with building better jets, but with creating sustainable, upgradable platforms that can evolve over decades. Open architecture designs are allowing software and hardware updates without complete redesigns, ensuring that today's aircraft can remain viable against tomorrow's threats. In space, hypersonic threats, and autonomous swarms, the future of aerial combat continues to shift. Next-level aviation is not a destination, it is a constantly moving target. Fighter jets are no longer isolated machines, they are nodes in a vast, intelligent network of warfare, powered by data, enhanced by AI, and protected by layers of digital armor. As technology advances, the line between science fiction and military reality grows thinner, and the skies above become not only faster and stealthier but also smarter and more connected than ever before. The modern fighter jet is no longer just a tool of war, it is a symbol of national power, technological sophistication, and strategic foresight. With each new innovation, we step closer to a future where dominance in the sky is determined not only by who flies faster or shoots farther, but by who thinks quicker, connects better, and adapts faster. This is the era of next-level aviation, and it has only just begun.